everybody, this is section 5.4 and we're going to look at midsegments of triangles in this section. Alright, so we are going to look at the midsegment of a triangle, and a midsegment of a triangle is a segment connecting the midpoints of two sides of a triangle. So if we look here, DE is the midsegment of triangle ACB, and it is connecting the two sides of the triangle, sides AC and BC. And a midpoint, remember, divides the side into two equal parts. So if you'll notice, AD and DC are equal in length, and so is CE and EB. And one thing important to know about the midsegment is the midsegment is parallel to the third side, and it is always half as long as the third side. So it's parallel to the third side, and it's half as long as the third side. Okay, so here we have triangle DEF, and they want us to name the midsegments and the sides that are parallel in triangle DEF. So if we look at the triangle, we have three sides, and we're going to have three midsegments here. So let's focus first on side EF. We need to find the segment that's going to be inside the triangle that is parallel to EF. So take a second in your mind and just look, think which one it is. Hopefully you said RT, and if we write that as a parallel statement, we would say RT is parallel to EF, segment EF. Okay, next let's focus on side ED or DE, either way. Okay, what side or what segment is parallel to that? So we have segment ED is parallel to, hopefully, you identified it as ST. So segment ST. All right, and then we have our final one we're going to look at, and this is DF. Sorry, not very straight. All right, and it is going to be parallel to RS. So that means that we are going to have segment RS is parallel to segment DF. All right, and what they want us to do here is they want us to identify the parallel segments and name them in an equation form. So the midsegments are half as long as the sides. So if we go back and we just start from, we started with DF first, and we know that SR is, or RS is parallel to that. What they want us to do is write that as an equation. So to write it as an equation, we know that DF, and then I'm going to put my equals in there. We have to modify it. So, and we have RS. Now, the midsegment is half the length of the other side. So to write our equation, we need to put in 1/2, and we're going to put 1/2 next to the longer side. So half of DF is equal to RS. Next, let's take a look at DE, and it is parallel to ST. So if we write our equation, we would have 1/2 of DE is equal to ST. And then our last one is going to be side EF. It's parallel to RT, so that means that half of EF is equal to RT. Okay, so here we have triangle QRS. So here's our large triangle QRS. And T, U, and B are midpoints on the triangle. So we want to know the lengths of segment TU, UB, and QR. So let me erase this. Okay, so first is TU. So TU is right here, and it is a midsegment. So we got to find the side that it is parallel to, and it is parallel to RS. We know that RS is 40. And remember, the midsegment is half the length of the third side that it is parallel to. So if we take 40 and we multiply it by 1/2, we're going to end up with 20, and that's going to be the length of segment TU. Okay, next we are looking for UB. So UB is right here, and it is parallel to QS. So now I want you to figure out in your head what's the length of UB. Hopefully we did the same thing as before. We did 1/2 of the side that is parallel to, so 1/2 of 50. So we get 25 is equal to UB. And then our last side is QR. So QR is the third side of a triangle, and it is parallel to TB. So because TB is the midsegment, and we know that measurement, it's the third side is 2 times the midsegment. So if I do 2 times 30, I will get 60, and that is equal to QR. Okay, and so here, this is good to put like a real world application for a midsegment of a triangle. So we have here a geologist wants to determine the distance across a sinkhole. They labeled it as AB. And choosing point E outside the sinkhole, she finds that the distances AE. She finds the distances AE and BE. So she measures from a point outside the sinkhole to the sides of that sinkhole. So she measures over to the side. She goes from A to E and E to B. She locates the midpoints, C and D of the segments, so you can measure those and locate them. So she wants to know the distance across the sinkhole. And again, you're not going to get too close to that sinkhole or in that sinkhole. So this is a good way to find your distance. So we need to set up our equation to find the distance. And again, DC is the midsegment, and it is equal to 46 feet. Remember, the midsegment is half the length of that third side. So AB is twice the length of the midsegment. So I know that half of AB is equal to DC. Now I already know what DC is, so I'm going to take my 46 to find AB, multiply it by 2. Do the opposite of dividing by 1/2, multiplying times 1/2, multiply by 2. So we get, let's see, that's 12 and 1. So it is 92 feet across the sinkhole. And that is it for 5-4.